see. Can you see the board?
Yes, ma'am.
Okay, cool. All right, ladies, y'all got your notes out? Everybody online, do you have your notes out from yesterday?
I wasn't able to take any notes because.
Fantastic, you can do it today.
Okay.
The first thing that it asked, and it asked you this morning, what was the 6 simple machines? You have an incline plane, you have a wedge, you have a screw. What's the other one?
A wheel and axe.
I know, but I'm just one.
They're on the next page.
Yeah, mine's not going to that next page. Okay, sure, fantastic. Mine's a different one. Okay, and then the other 2 are which ones?
Other 3.
The other 3?
It's lever, wheel and axle, pulley, incline plane, wedge, and screw.
Okay, can y'all please open up your PowerPoint so I can see if I'm skipping something? Because obviously I am.
Is this Monday?
Just today. It's on today's baby.
Oh, it is.
Mm-hmm. So the first thing it talks about is the reason why we use this. We're on the 4th slide now. Keep going. Awesome, right there. Fantastic. Why we use this, the reason why we use different types of levers and pulleys is for mechanical advantage, okay? So it says ratio of the magnitude of the resistance of the effort force, ratio of the distance traveled by the effort and the resistant force, and calculates ratio along with designing speed, distance, force, and function, okay? So, next slide, please.
Ms. Long,
Yes.
you said you wanted us taking notes, correct?
If you already have notes, just check your notes. If you feel like add something else, you can.
Do you want us? Should they be in our engineering notebook or our ISN?
I told the kids that it's going to be in the ISN book.
Okay.
Because unless it specifies on project lead the way it needs to be in the engineering book, we're not going to put it in there.
Yeah,
Okay?
it said on the PLT website that it wanted us to put in our engineering notebook.
Well, I'm going to put these in mine, so you can do either one. I don't care. But thank you. I appreciate that, sir. So if we're looking at this, what this is doing is showing you two different boxes scenarios. So when we're talking about something, we're talking about a system, okay? So this is what we're looking for. The system that we're looking for is just the box itself. If you look, you will have an effort force, and you're also going to have a gravity force. So if I took this one and drew a free body diagram, my free body diagram for this box would be, I would have this, but then I'm going to have that. This here is my force, gravity, on the box by the earth, okay? Up here, we're going to have force applied on the box by us, right? Because we're picking it up. This is the force diagram for this scenario here, okay? But the ramp, as you can tell, has different vectors on it. So if we were looking at the one with the ramp, we're going to have our force, our force applied on the box by us, and then our force on gravity on the box by the earth is going to be different. You're going to be looking at the vectors. Do you see how long this vector is compared to how short this vector is? That's the reason why we have mechanical advantage. We're using this ramp here. What is this called compared to the 6 that we just learned? Incline plane. So this incline plane is helping the person use less effort, and it can go further because I'm using a simple machine to do that. Does anybody have any questions about this? Because this is important. Anybody online have any questions? Is everybody good? Fantastic. So the magnitude of the force, which is the effort force magnitude, is 4 times less than the magnitude of the resistance force. And distance traveled by the force is the effort of the force traveling 4 times greater distance than the resistance force. So this is a whole lot easier, a whole lot quicker, and takes less energy, okay? So, what is your magic number? MA is greater than 1, less force, greater distance. MA that's less than 1, greater force, less distance. As long as you understand what mechanical advantage number it is. If it is 1 or if it's less than 1, that's what we're looking for, okay? Here, this right here. Do you have that written down in your notebook? This is one of the equations that you're going to be using in class. So what I'm going to do is I'm going to go over here and I'm just going to write on my board IMA equals dE over dR. dE equals distance traveled by the effort force and dR is the distance for the resistance force. Now I'm going to tell you the best thing for you to do is to start writing them down on some place that you'll know. I personally will have it on a Post-it note around the room for you. But you need to make sure that you understand what the variables stand for. The variables are very important, and what we're trying to find is very important. How many of you online had tried to do the math last night and was having problems? Anybody? Online?
I don't think I even tried to do that.
Fantastic. We're going to do the math today. So, actual mechanical advantage, which has a different equation, right? So, I'm going to do that one now. AMA equals FR over FE. FR stands for magnitude of resistance. And FE stands for magnitude of the effort. Now, the question that I have, Jesse, what is a resistant force and what is an effort force?
The resistant force is like the friction, and the effort force is you pushing against it.
Perfect. So if I had a free body diagram, which one is my effort force and which one is my resistance force, ma'am?
The resistant force is the arrow going down.
Which is our force gravity.
Yeah, and then the
Force applied.
force applied is the effort force.
Perfect. Does everybody understand that? Because you're going to have to know that when you start doing some of the math calculations. Kate, are you good?
Yeah, I'm just writing.
Okay.
I have the formulas written down, I'm just writing like the F on it.
No problem. Okay. Here is another incline plane again. And we're showing it again on how much force is applied versus the effort force of that incline, kind of like a roller coaster would be. So now we have a new one that we learned is, and this is actually showing you how to do the equation. Is everybody ready? So if we had an equation like this, and it tells us this is 4 feet, this is 15 feet, we know that IMA, what are we looking for? What does IMA stand for?
Stands for the distance traveled by resistance. Car.
Ideal. Go back. IMA is ideal mechanical advantage. Make sure you have that. Okay, so Kate, let's look at this equation. So, what is the IMA of this inclined plane above? First thing that we're going to do is it tells us IMA is equal to DE. What does DE stand for?
DE is distance traveled by effort.
Effort. And Kate, what is R?
Distance traveled by resistance.
Resistance. Okay? How can we find what my effort and my resistance is? Effort's here, resistance is here, right? So what is, using your calculator, open it up and tell me what the IMA of this inclined plane is.
I don't know.
Sound good. Guys at home, do you know what the answer is to this question?
I can't see anything that's going on, and I cannot find the slide you are on.
Okay. Well, how about if I move you here? You see it now?
I still can't get on the PowerPoint.
Elijah.
It won't let me. Like,
Elijah, are you going through the one on 004, the
Yes.
1.1.1? Because that
No,
one will open up. I don't know why. The other one's like a giant PowerPoint or something. It won't open
It is, and the reason why it's a giant PowerPoint is my son was trying to test how to do a video with it, and it's my fault.
Oh, I was wondering because it was like everything I tried to open it with was like it's over 30 megabytes and it can't open. And I was trying to figure out how,
You do the,
like how many slides had to be.
yes, sir, you do the 3 dots on the side, and you go down and open a new tab, and then it gives you a download section. But it's okay, because I'm doing it today instead, because I think this is working better. Now, okay, Kate says is 3.75. What is my unit?
No, it's just feet.
3.75. If you're doing, what are you doing here? You're dividing, right? Well, you're exactly right. It's just, this is the thing. 15 feet divided by 4 feet, feet cancel out. So it is just now 3.75.
Miss Sloan,
So in your equation,
Feet cancel out.
where's your equation? Where'd you write it?
I haven't written it, I did it in my head.
Okay, so you're taking,
Or like I read it off the board, I didn't write it.
all right, you ready? You're doing 15.0 feet, correct? Dividing that by 4.0 feet, correct? Feet divided by feet, cancel out. And then your answer is with no units. If you did it times, Kate,
It would be feet squared.
thank you. The answer would be feet squared. It's okay, Kate. All right. Hunter, you have a question?
But one divided by one.
I did, but you just answered it for me.
Oh, good. And so since it's 3.75, where'd they get this ratio 38-1?
They rounded up.
This here,
They rounded up
3.75.
their answer and then put it to 1.
Right. Everybody at home, okay. Can you see on my board? Hunter, can you see it now?
I can see it.
Thank you, Izzy. Okay. So here's another one. And it's asking you now what the AMA for this inclined plane is. So I want you to do your calculation by yourself. Write down what you think it is so we can check the answer. You have to find out where the resistance is and where the effort is. We got all kinds of numbers this time. So the first thing you're going to do is you're going to take your 20 pounds and you have your 50 pounds. Those are the two numbers that you're looking for. Why are we not doing the 15 and 4 this time?
Because it's AMA.
Because it's AMA. What does AMA stand for?
I forgot. I didn't write that down. It stands for actual mechanical
Yes.
advantage.
Okay? Actual mechanical advantage. So write that down. Make sure you have it on your notes. Questions so far, anyone?
So you would do 50 divided by 20?
So what you would do is you do 50 divided by 20, which will get 2.5. It would be a ratio of 2.5 over 1. But then what they did also is they found the efficiency.
Percentage.
What is efficiency?
Percentage.
A percentage of how effective something is.
Yes.
So when you're
It's 67.
So when you're talking about efficiency, you're talking about if you're going to buy a washing machine, you're going to buy a dryer. Efficiency is important because that tells you how much energy you're going to use.
Yeah.
So to be able to do that, you're taking your AMA, your IMA, and times it by 100, and you should get 67%.
What does AMA stand for? Oh, never mind.
Ideal mechanical advantage.
Yeah.
Right.
So then it would be 2.5 over 3.7.
Yes, ma'am. Times 100.
How do we know when to use which one?
Well, depending on what we're doing. And can I say, if you want to find efficiency, you have to do them both.
Yeah.
And if it asks you for ideal, you do the ideal one. If it asks you for actual, you use the actual one.
Whatever it asks.
Yes, ma'am. So what you're going to have is when you see your diagram, you're going to have both. So how can I figure out which one is which? This is pounds. So we're talking pounds. Which one are we using? The IMA or the AMA?
The AMA.
Okay, do you understand? Cool? Everybody at home, are you okay? And
Just to be sure, when you go to write your like where you put 2.5, where you go to write your ratio, you have to round it up to the 10th place.
correct.
The decimals. Okay, let's make it
You
sure.
are exactly right. Very good point. Thank you, sir. That was a good question. Okay, so that's inclined plane. That's just it. Draw you a line on your paper and put the word wedge, because that's where we're going to now. Now, when we're using a wedge, you use it to split wood with. The best one that I can think of as a wedge would be if you have like something to chop wood with. Now, by this week, you're going to have to find each one of these simple machines at your house and take a picture of only one of them. Okay? But you got to prove that it is a simple
I
machine.
thought you said 3 of each.
I changed my mind to one. I'm not going to kill you. So when we're talking about a wedge, it is a function as a moving inclined plane. Inclined plane kind of like would be the door stopper that I have in my room that I keep the door open with, okay?
That's not a wedge.
It can be considered a wedge depending on what it's doing.
It's a wedge when you can put it in.
Exactly. Thank you, Kate. Good job. Okay, so when we're using a wedge, our IMA is going to be distance traveled by the effort divided by the distance traveled by the resistance. So please write that on your paper.
So we do,
So you're going to do your IMA again, which we know what IMA stands for now. It's going to be DE over DR. DE is the distance
travel by the force,
by the effort, and then the DR is the distance traveled by the distance
so it would be,
by the resistance.
so it would be 10 divided by 30.
And do you see the L and the H? All right, baby? That's your length and your height. So I would draw me a little illustration for that so I would know. So we're going to be looking at these equations now. So, what does that stand for, this little symbol?
What are the numbers on the wedge, Miss Sloan? I can't see those.
10 and 3.
It's what?
10 and 3. Can you see it better now?
Yes, ma'am.
I haven't moved back because I was thinking you were on PowerPoint, but we're all good. Okay, so parallel to the height. What does that mean?
What is parallel?
So it would be 10, and then parallel to height, I don't know what it means.
Same thing.
I don't know.
10 divided by 3.
L isn't parallel to the height.
Yes, it is. Well, no, it's perpendicular.
Perpendicular.
Well, it's that parallel.
It's perpendicular.
It's perpendicular.
Parallel is two lines.
Exactly. Right beside each other like that.
See?
Like beside each other. Okay? So,
11.
only thing we're doing here is we're just taking our 10, dividing it by our 3. Same thing we did before, right? So what do you think AMA is going to be?
3.3 continued.
Okay? Now look at the structure with the AMA. Here we are, ma'am. We've got these two new things here, right? We still have this, and we've got this new, don't we? So,
That's the sun.
what is FR?
FR is the resistance, which will be
Magnitude of the resistance, right?
250, right?
Okay?
And then the magnitude is,
And what is FE?
well, would it be 700 or would it be 1400? It will be 1400, right?
So we're going to take the magnitude of the resistance and divide it by the magnitude of the effort, okay? So it says 700 divided by,
So this is 700?
just 700. Because if you can see, this wedge here, the main thing it's doing is it's going in this, and it actually has equal amount of pound force here because it is a wedge. So these numbers should match. But they want you to show you that when the wood goes in, when the wedge goes in here, the wood is separating with this kind of force, which is equal, which will make it straight. Anybody have any questions about the wedge?
It's
2.8, and it's a ratio of 2.80 to 1. Anybody online have a question?
Hold on, don't pay that.
So just to be sure, the effort force is the 250 pounds and the resistance is the 700, correct?
The resistance is 700 and the effort is 250. So the resistance is where you're trying to put that wedge in and it's resisting breaking apart and you're using something like a hammer to hit this in. So that's your effort. Does that answer your question?
Yes, ma'am.
Thank you, sir. Questions about a wedge? Okay, what is the efficiency? So what are we going to do this time for efficiency? Same as what we did before. You're going to take your answer by your IMA divided by your AMA timesing 100. So go ahead and do that.
Wait, so is the IMA on top or the?
Yes, it's IMA. I think so.
I got 117, so I don't know if that was correct.
AMA over IMA. Yes, ma'am. And times that by 100.
84%.
84% is what she said, and it is 84%. Everybody good?
I did not get that.
Sir?
I did not get that.
Okay, so did you take 2.800
Oh, I just did 2.8.
divided by 3.330?
The AMA over IMA or IMA over AMA?
It's AMA over IMA.
That's why I messed up. Then I put
All
I.
right, that's okay. We all messed up at the beginning. We're all good now.
Okay.
Now we're on a screw. Now a screw has an incline plane wrapped around a cylinder forming a path and a pitch. Wheel and axle used to create rotational motion. Okay, so on your paper, write screw. Okay, properties are change, rotationary motion, and linear motion using to thread faster, larger MA, and larger amount of friction lost. So when we're talking about a screw, we're talking about the effort armed distance. The pitch is the difference between both of the inclined planes here. And you will also see, when you do these, you will actually see a thread information. Do me a favor, write that down so you can see it. Because this one's a little bit different of a diagram. The wedge, we had certain places that we were going, right? When we were talking about the inclined plane, certain places. But now we've got to figure out where we have to do. Is everybody good?
No.
Miss Sloan,
Yes, sir.
can you turn your camera like a little bit more, I guess, left so we can see the leftmost of the other way?
Other
Sorry.
way.
Other way.
All right.
Yes, ma'am. That's
Is that better? Okay.
Yes, ma'am.
You know this is on the PowerPoint, right?
The one you posted today or the one you posted
The
yesterday?
one I posted today.
It's not on there.
Not on there.
It goes like lever,
It has
and then I think
Yeah.
and then pulley, and that's it. It just
Wheel.
stops after that one.
Has pulley and wheel and axle on mine, but not no screws or wedges.
That's what it's
Thank you. We're all good. I have to post the right one. This man is great. Okay. Everybody online, do you need a few more minutes? Are you good?
Are you gonna post this afterwards?
Yes.
Okay.
So the question is, how far will the screw with the 13 thread per inch move literally if you turn it one full rotation? How will we know that? It's asking you how many inches.
It will move.
13 threads per inch, increases from 13. So pretty much we just gotta.
It'll move 1/3 of an inch.
1/13 of an inch. Very good. Wow, y'all doing great. Look at y'all. Okay, so here is our equation again. We're going to do an IMA and an AMA again. So our IMA is DE divided by DR. Same things we had for the wedge. Same thing we had for the incline plane. All right. DE is one rotation of the effort arm or the circumference. And DR is the line distance traveled during one rotation of an effort arm or pitch.
This is gonna take a while.
I understand.
Distance traveled. What's it, 35 slides? I'll take a while.
Okay, well, we're not gonna go all that far today. We're gonna stop in a few minutes. So your IMA is your circumference divided by your pitch. When you talk about your circumference, that's 2 times your pi times your radius divided by P. So write that down. So, what is the IMI? If the screw is above, is an effort that is applied to 8.0 inches long wrench.
That's a good question.
So remember, do you remember what pitch is? Pitch is this right here, right? What is the circumference? Up here. So let's look at these numbers here because they're going to help us.
What's the pitch number? Like, what's
Is the diameter of it.
1/4?
So the diameter.
Diameter is 1/4, correct. Yes, Kay, very good. So if we look at these numbers, D is diameter, what's 20?
20 is
20
the fraction per inch.
Thread count, right?
No, D. I don't know.
And this right here is just basically telling us if it is or if it is not. Forget what the C was. Is it NC or a C that stands for that?
Wait.
Okay,
Okay, so how would you?
I
there you go. So we're gonna take 2 pi. Where did I get my 8 from? Here's my applied force, right?
So the 8 is the radius?
8 is the applied force. The effort of the applied by an 8.0 inch long wrench. So that is, so in other words, think of a wrench up here that's turning this screw, right? And it tells us that applied force is 8.0.
So why does it got it for R? Is what R be radius? I'm confused.
Yes. So 2 pi radius, we're looking at the wrench is the radius of the effort force. Does that make sense now?
Yeah.
Okay.
And it's divided by 1 inch over 20.
Yes. Why are we doing 1 inch over 20?
Because that is the thread.
Very good. So we have to make that into a fraction. Put it in your calculator and see if you get it.
Yeah. I'm brain. Okay, so
This is the last one we're gonna do. We're gonna stop here.
Oh, wait, it has to be like something like that.
Yes.
Miss Long.
Rima, right?
Well, this here is scientific notation, but
Miss Sloan.
hold on just a second. I'll get one, Kate, real quick. All right, let's see what we got. Yes, sir.
2.512? No.
Yes, sir.
Well, we got the scientific notation.
Yes.
We're writing 1.0 times 10 to the third power. Why won't we write 1.00531 times 10 to the third power?
Because of rounding. Now, I'm going to tell you, if you write it out completely, it's not wrong.
Okay. I
Okay?
was wondering because when I said that, I would just think of 1 times 10 to the third power. Think of all these other numbers.
What did you get?
You got that?
I got 1.0053096.
Yeah, and then you gotta, how did you even get there?
So only thing you did is you rounded it 1.0 times 10 to the third power. You got the right answer, right?
How do you get it? How do you type it?
Can I borrow that?
So I got it right.
Yes, you got it right, Kate.
How do you type? I didn't know.
I'm gonna change it to scientific notation, baby. So you're gonna do AB. You're gonna do 2 times, do we have pi here somewhere?
Somewhere. I just put 3.14.
Look at like under the clear button.
Okay, and then we're going to times that by 8.0 down button. And then you're gonna have 1 divided by 20. Okay, I'm sorry, I was helping her. Now, guys, are you still there? Because my battery's low. Fantastic.
Is that?
It's trying to. I'm looking for, I'm gonna have to unplug that. Guys, can you still hear me?
Yeah.
Okay, so what I want you to do now is these were for the notes for today. Now, what I would like you to do now is I would like you to go to activity 1.12. Y'all too, activity 1.12. And what I would like you to do is if you tried, I want you to try to do a couple of questions on there. So when we come back tomorrow, we'll talk about the answers to these math questions and we'll continue with the PowerPoint. Anybody else have any question that's online?
Yes.
Online.
Miss Sloan, so have we talked any more about the engineering project?
We have not talked more about the engineering project, but we can right now if you have a question.
Hey, Kate.
Were there any resources provided for how to contact engineers or?
What I'm asking you to do is I'm asking you to find someone that you can call to talk to. There's no specific person that I want you to talk to because this is just people in our area. Are you not being able to find anybody?
I have someone I can contact, but I know some of the people who had more niche engineering careers, such as petroleum or nuclear, might have more trouble or are having difficulties finding someone to contact.
And so if you're having a difficulty and you have one that you cannot find, tomorrow I still have the bin with the rest of them. And remember what I did the other day, had you trade them out? If you're having difficulty finding one for a certain one that you pulled, you can come back and choose from the rest of what I have left.
Okay. And
That's
for
okay?
yes, ma'am. And what questions are we supposed to ask them? Because the rubric made it seem like there was something we were missing, like there was a part that had like pretty preset like questions to ask.
They're not preset questions. They're the questions we decided online on Friday. Remember that beautiful list that you sent us, Lex?
Well, I was just wondering because those were kind of like 30 questions we came up with very quickly in a very informal setting. I didn't know if you had anything more.
No, I do
guess-
not at this time. I do not. At this time, I want us to do the ones we decided on, and we're going to use those.
Can you explain project?
Yeah.
I will explain it to y'all when I get off of here. So Lex, the questions, and if you want me to, I can share it with everybody. I thought everybody could see yours, but I thought they were really good questions.
Okay. I just didn't know because I didn't know if you were gonna make a public thing for you. I was just putting it on there so everybody could see, but I didn't know if you're gonna make like a follow-up post, like officially saying, okay, these are the questions we're gonna use.
If it makes you feel better, I can make an official post and it'll be 5 questions.
The page I had you want to look at.
Okay.
Would you like that, Lex?
Okay,
Yes, ma'am, that'd be nice. Thank you.
I will do that. It'll be 5 simple questions right now. And what you'll need to do for Friday, what you have to have is you have to have a PowerPoint, and you can either videotape yourself talking about what you saw or what you talked to them about. Would probably be my best guess.
Could we communicate them over email or something if we are not able to call them?
Yes.
Okay.
Yeah, and if you do that, just do it like a presentation and say, I talked to so-and-so and this business here, and then just go over the 5 questions that you asked them.
Okay.
And it's just a real quick video that you would have to post to give me.
So I have to call a marine and ocean engineer.
Anybody else online? Because I don't want to hold you all for all class period.
Also, my other question was another thing. I think a lot of us had difficulty completing yesterday's assignment in Project Lead the Way. I know you said 1.1, but we were looking at that and there was like a lot of, it was very large assignment it looked like.
Very good,
Like,
Lexi. Exactly. So based on what I got feedback from y'all yesterday, I've decided I'm going to do it this way instead of trying to do the distance learning thing because it is way too much. I look
okay, that's
and
that
there's
works.
no way y'all can do that.
So we're just going to be taking notes and getting on calls, or
Yes,
like working
sir.
with you. Okay,
So
that's-
it's going to be correct. So what it's going to be is I'm going to videotape every day in class if we're lecturing. You don't necessarily have to be online unless you have a question, but then I will post this recording after we get off of here, and then you can go back and watch it later if you need to. And I'm going to
Okay.
try to do that every day so that you'll have something that if you're at home, you'll have something to watch to feel like you're not missing something. And I'm going to try to make this a little bit of a lecture. Today was a long lecture, but usually it's going to be like 15-minute lecture. And then you're going to work on your projects, and we're going to start building simple machines when y'all come back tomorrow.
Sounds good. And what was that about taking pictures and of simple machines in our house? Is that something you're going to
Yes.
explain to us on Wednesday, or?
Yes, but what I was telling them here in class, and I'm telling you online today, start looking around at your house to see if you can find, all of those simple machines and take a picture of an item that says it's a simple machine. Why?
Okay,
that's
just
gonna be-
one?
One, yes, sir, and that's going to be your test this week.
Okay.
We can't find one.
You'll find one. I have a feeling. Anybody else online have any questions? Because if not, I'm going to get off and I'm going to help these ladies now.
Bye, y'all.
So do you know what you need to do today?
Yes, ma'am.
What you need to do
Yes.
is you need to go into Project Lead the Way. And you will need to, you see my screen? I have to share it, don't I?
Yes, ma'am.
All right, everybody, can everybody see my screen? I'm going to Project Lead the Way, hopefully. Our system's not letting me get on. I'm gonna say third time's always a charm. So you see my Project Lead the Way screen, guys?
No, ma'am.
What do you see right now? You see my welcome back?
Yes, yes, ma'am. I see it.
Fantastic, thank you. I just need to know, make sure it was working. So what you're gonna do is you're gonna go into, I gotta get on yours first, so give me a second. Go on your Project Lead the Way, you're gonna go into 1.1 mechanisms. And you're gonna go down to oh, that's right. I attached it on your Google Classroom. I forgot. So let's go to your Google Classroom. That'll be the easiest. Okay, besides today, what I had listed, I also had that. Yeah. Struggle's real today. This handout here. Now, this handout here, you should have access to it, each one of you. So what I would like you to do today is I would like you to do the lever part. If we look, Simple Machines lever, you can do that. You know the formulas now. And that's where I want you to stop. So I would like you to do 1 through 4 on this handout. Ladies, do y'all understand? 1 through 4 on this handout? We are on Google Classroom. Today's assignment, there is an attachment that is a worksheet. Does everybody online understand?
Yes, ma'am.
So when you get here tomorrow, I need you to have that written down. Now, where are you going to write this down at? You can write it down either one. I don't care if you use your engineering notebook or if you use your ISM book. What I just need is I need the diagram, the formulas, just like we did in class today on the lever. Is everybody good?
Yes, ma'am.
I'm going to go ahead and stop sharing this, and I am going to sign off. If you would please do me a favor, in the comments section, if you would please write your name, type your name so I'll know who was here. As soon as you do that, you may get off and work on those problems. Thank you.
So,
Oh. What are we doing now exactly?
oh God. Okay,
1 through
so
4.
this is gonna be
Yeah.
so
Okay,
exciting.
She's
we
like,
have
I did our revisit today in class. I'm like, we didn't do anything with the lever.
Hey,
Yeah, and
did
but
either of you
and
do
she kept
anything
saying,
yesterday?
I had to confirm with her. Yeah, no, nobody did anything yesterday. That's why I had to confirm with her. I was like, so you're acting like we did 1.1, but I want to be very clear, we did not do 1.1.
None of us did.
No, yeah, nobody did like anything else. And
How
glazed
do
over.
we do the
I
lever?
was working on AP while she was.
Bro, like I'm trying to take notes and she's going so fast, and I got like all the way to like I wrote down actual mechanical advantage and then skipped all the way to the screw. So like I'm missing a lot.
Let's
This is what I did.
Go look at the group chat.
She recorded it, so she's gonna post
She
it.
just reposted. She's gonna repost it. I can go through and get that. But like, I'm on different websites right now trying to figure out actually how actual mechanical advantage and all that works because I was like not paying attention.
It's not hard. It's just I don't know how to do it for lever. Like,
Yeah,
you didn't go over that part, not yet.
I'm just gonna aggressively Google it, and then okay, so we need to take a picture of a lever or some type of simple machine in our house. That's gonna be fun.
I'm working on the Renaissance.
I'm about to just go take a picture of an axe and bring it to school.
Okay, well, I'm gonna go. I'm glad we got that cleared up, and it didn't really help with the engineering project, but it's still due on Friday, so I was gonna like not do it, but now I guess I have to do it. So
Have either of you watched the videos for the Renaissance?
Yeah, like here's the thing. Get to my notes. She's like, "Oh, if you don't know how to get in contact with one, I just give you another one to make you even more."
no, that's what I'm saying. Yeah, like she's like just call one. I was like, it's not like there's such an exclusive position that they have public phone numbers, and it's not like they're so common that you will bump into one on the street. So it's like, it's just the job. Like, how are you supposed to just call one? Like, oh my God! Again, guys, if I were you guys, like again, I know a couple actual civil engineers that I can talk to, but if you have one that's ridiculous, straight up just make up stuff. That's what I would do if I had like something super difficult.
That's
that
exactly
like.
what I'm gonna do.
Like seriously, if it's a phone call, what are you gonna do? You're gonna be like, "Oh, bro, me and this man, John Ferdinand, we had a great conversation. We talked. He said, bro, I answered your 5 stupid, silly little homemade questions. I love my job. I'm a curious, questioning person. I can make this up in like 5 minutes. I can do the entire project. So, and then just throw it into a
industrial.
Okay, I'm trying to figure out how to do the work for today. To be honest.
Hmm.
I got
Yeah, that too.
industrial engineer.
I'm just gonna mark. I'm just gonna mark. Whatever is done. The stuff I didn't actually do. Hashtag 003 is done.
So the effort force, if that's 15, and it's 5.5 inches away from the fulcrum, then you multiply that, and you'll get your effort moments, which is 82.5 inches pound. Huh? 82.5 inches pound.
Middle
Pound.
ages.
That's what it says. Go look at it. Go look at the thing. I have no idea. And then the resistance is 36 2/3 of a pound. Like, let's just slide that 2/3 of a pound on there for no reason whatsoever.
Mm.
And then divide that by that, which gives you 2.2 and 1/4 inch is the distance with.
Yeah, I'm gonna Google how to do this stuff before I do it, but I gotta go, so I'll talk to you later,
Okay.
man. Bye. Wait, what other? Oh, yeah.